Hey everybody, welcome back to what is part 18 in this AMF Lowrider restoration series. If this is your first time watching this video, click the link up above. Will take you to the first video in this series. In the last video we closed the gear case below as well as taking care of the lifters and whatnot, previously putting the oil pump back on, thus completing the assembly of the bottom. And as we work our way up the engine, we're working on the cylinders now, and we have our rings and we have our pistons, and these pistons accommodate the cylinders that are now bored out 20 over. And we're also going to be taking those rings, we're going to be measuring them with the piston to determine the ring gap and cutting them as necessary. However, one thing that we do have to do before we begin this is, from previous videos, you may have seen that for whatever reason, when I got this engine back from the machinist, it was missing a base stud. I have been able to order a base stud, believe it or not, from Harley-Davidson, from their parts department at my local Harley dealership. I now have that stud, so we're going to be installing this stud. This is an interference fit, so this is not a standard installation. Here's the part number for that for my model. So this stud's going to go in first with red Loctite. We have a procedure for this. That'll be our first task before we get underway with the other items. So that's it. We got a lot to cover this episode. Let's get started. Because of the way my current base nuts here are designed, I don't want to use these for this project, so I'm going to just put these to the side and go pick up some at the local store. I'm going to run to Lowe's and get 2 of them so I could tighten them on each other onto the stud for this task. Lowe's has one of these test stands that includes 7/16 20. Plug in the stud in here to test. This is the extent of any 7/16 20 you'll find at Lowe's. Home Depot, however, actually carries 7/16 20. Wanted to point this out in case you want to try and go to Lowe's to find a nut that's in 7/16 20. So ideally what we're doing is we're going to put one nut on the stud, and then we're going to chase it with a second one, just like that. And then we're just going to lock both onto each other and then tighten from the top one, so we have a way of tightening the stud into the block. That's all there is to it, pretty much standard. So I'm going to take a measurement of the existing studs on this side. Use my calipers. This is not an exact science, but pretty close, especially since the top of the other one is different shape. It's more rounded than these, but we'll get it close enough. And I got the first one, and I'll match it against the second and third. And they're very close, obviously. And this is what we're looking at for our measurement, and I'm going to lock that down. And as I turn it, I'll take incremental measurements against the block till I bottom out. I definitely don't want to overturn this because it is interference fit and I don't want to cause any damage. I'm rotating the engine now to distribute a thin coat of oil onto the flywheel. We can see here after a few revolutions, just a very thin layer is formed. You see here I've cut out some strips of paper. This is regular 8.5 by 11 printer stock paper. Initially I had folded it a couple of times to make it thicker, and then I had determined that a single sheet thickness was ideal for this. About half of the strip of paper was allowed to soak in clean motor oil. Once the paper is prepared, it'll be slowly inserted into the engine like so, as to go under that hole, the threaded hole, so that when any of the debris is there, as we could see, it could be slowly slid out from the engine with it. So now we'll just tighten these 2 nuts against each other. And then we'll insert the piece of oiled paper. Then I'll be using an ample amount of red Loctite 271, something I rarely use. The threads of the stud are completely coated with red Loctite. Stud is given a few turns by hand first until resistance is felt, and I move over to the wrench. This will now be turned in with the wrench, stopping to check with the calipers at regular intervals to see how close I am. Once the height of the stud is in the right position, I'll stop what I'm doing. I'm going to pull out the paper now. Now I'm going to torque both of those nuts in the opposite direction as to loosen them, so I can remove them both from the stud. Check one last time, everything looks good. And we'll let this sit up for a few days to dry. Turn our attention over to the cylinders and rings. This next operation will be measuring the bore of the cylinders. Be doing both of them, obviously. This will be the last operation I do both together. It's going to start with the calibrating of the micrometer. This one's already been calibrated, but I'm going to go through the motions again. This is a 3-inch to 4-inch micrometer based on, obviously, the bore of the cylinder you're going to be working with. So we're going to do that calibration now. We're going to use this right here. This is actually a calibrated piece. I've had this 4-inch measurement calibrated on equipment much more expensive than anything I have. So I know that this is good. And this is going to be my baseline. And this is the preferred method I'm going to use. So I'm going to clamp this very gently into a vise to support it. And I could take this micrometer and just open it a little further than 4 inches for the purpose of this task. But it's very important. I want to clean all of the surfaces. Any amount of debris that's on there could throw off this setting very easily. That includes both ends of the micrometer as well as this calibrated length of metal. And then I'm going to insert it in, and then I'm going to collapse it down to get a reading, which I expect obviously to be exactly 4 inches ideally. And we're going to see how far off the micrometer is. And we'll inspect. We come to find that it is off by 0.2 of a thousandths of an inch. Pretty good. So we see that the stock bore for an 80-inch is 3.498 inches. So we'll write that down, 3.498. This one is bored out 20 thousandths of an inch. So we're going to add on 20 thousandths of an inch to this. Do a little quick math here. Some addition, if I remember how. So we got 8, 9, 2 is 11, carry to 1 is 5. And then we end up with 3.518 inches is going to be the expected bore of these cylinders. So we're going to take the micrometer now. We're going to start closing it back in from the calibration setting to 3.5. That's going to be 3.5 and 0. So now we're at 3.5 even. And now we're going to roll this back out. 5, 10, 15, 16, 17, and 18. So now we got 3.5 and 18, 3.518. And now we're going to lock this down. This micrometer is now set up as a reference for both the bore and the bore gauge, which is now going to be set up next. I had specifically selected the length of the extension and the shims that you see here. I'm actually using 2 shims, such that when this entire assembly is assembled, the length of this, as compared to the micrometer, is just slightly bigger as demonstrated right here. Enough that when inserted like shown in this manner, the compression from the back is shown. The needle up top does at least 1 full complete revolution, but less than 2 revolutions. So we can see as I insert it into the micrometer, it makes, in this case, 1 full revolution. And now I'm trying to find the highest point of deflection where it meets its apex and then comes back down again. This is the mark I'm trying to find. This is 0. So now I'm going to rotate it a few degrees to get it into the ballpark. I don't think this is going to be exact, but I'm going to keep doing this until I get it right where I think it should be. I'm sorry for the bad camera angle here, but there's a lot to work with, a lot of distance between these 2 test equipment pieces. And then we can see it looks like I overshot it a bit. This time I counted the number of tenths, so. And I'll try it again. Now it looks like I'm off only by 1/10 at this point. Make a final adjustment, and we'll take a look at it one last time. Now it's perfectly set at 0. This gauge is now calibrated for this bore size. So I got these cylinders situated on the bench left to rear, exactly as they'd be found on the bike. And we can see this indentation, this notch will be found pointed towards each other on these cylinders. And as you look at them, You'll see that in the book I've drawn this sort of silhouette showing the top, middle, and bottom where I'm going to be taking measurements, but also at the 0, 60, and 120th degree from a 0 point that I'm going to explain. Where that notch is going to be the 0 point. So if you look here, this one I've annotated with a little bit of whiteout, marking these 3 points, 0, 60, and 120. Where the notch is 0, right there. I'm going to take a measurement, obviously, across 180 degrees from each other, like so. Same measurements will then be taken on the other cylinder. We start, of course, by cleaning out the bore. I'm going to be cleaning it and oiling it at the same time. I'm using Rem oil for this task. We're going to start by lining to that first 0 point that was created. We're going to drop it here in on an angle so we get both sides in, and then sort of straighten it out so it compresses. And then I'm going to move it back and forth until I get the highest point reading on the meter to determine how far off it is from 0. This is done with a little extra dramatic effect, but it illustrates where that apex is. By 0, you can see where it tops out and then moves in the other direction. And this one is less than a 1/10 thou. I then drop the tool forward to relieve spring pressure, and then drop it down to the middle position and pull it back up to set up for the next reading. Now I'm going to move it back and forth again to find out where that apex is. And the second reading, again, is also under a 1/10 thou. Finally dropping down to the bottom of the cylinder now in position 0. Setting up for a reading, moving it back and forth to find the apex. And we see that this one is also less than a 1/10 thou. This is symmetrical from the top all the way to the bottom. It's even, doesn't flare, anything like that in this position. So now I rotate the cylinder 60 degrees clockwise. Now I'm going to repeat the entire process in the exact same manner. And finally the last position. I'll be doing the exact same thing to the front cylinder now. And the verdict is less than a 1/10 of a thousandth for both. My tolerance is 2/10 of a thousandth, so these are good, and that concludes this portion of the testing. This is the last time that these cylinders will be worked on together. One's going to be put off to the side until such time as they're mounted back on the engine. I'll be separating items out that I require for the rear cylinder only. This includes the piston and the rings, which are all in one bag, so I'm going to have to put the ones I need in a separate bag so I don't mix them up. So I made just little envelopes like that out of paper, real simple. You see that the rings are labeled for their placement in the diagram on the original packaging, and that's why I'm putting them in these respective containers so they don't get crossed as to where they're supposed to go. I'll deal with the oil ring later, number 3. I'm not worried about that now. Now we're going to unpack the piston. We got the wrist pin. We got the clips. These are the circular spring-loaded ones. Then obviously the piston itself. Indication shows 20 over from 1340. No other actual markings or indications as to which direction it's supposed to sit in. The piston fit in cylinder calls for 0.02 to 2.5 thousandths of an inch. Since Drag Specialties provides no information whatsoever as to the actual location for the skirt measuring point for the piston diameter, I did 90-degree offset from the center pin in my initial measurement. I'm showing here where I got those locations to make that measurement. Measuring at this location, though, came up to 3.514. This was out of specification by over 2 thousandths of an inch. Took these findings back to the Shovelhead group, and JB recommended measuring it much lower on the skirt, right past this detent over here, and measuring upward until I found the maximum diameter. And I actually found it right about here, lower on the skirt. Maximum diameter turned out to be 3.5 and 15/6, so 3.5156. So I'm going to do the feeler gauge method right quick because it was one of the topics on the Shovelhead forum today. So I'll lower the piston in from the bottom, and we could see I've lined everything up. And this is a 0.0015 just for control. And we could see that it slides through with no problem at all, even in the widest diameter portion. You do have to hold the piston just right so you don't bind it up as you do it, right? But as I complete that task, I take out the 0.002. In this case, as I drop it in, okay, from the side, there's a million miles of room, no problem at all. But right as I get to the middle, We can see it bind up right over there, and I didn't expect that, really. Not at all. So I pull it out, and I'm going to move to the other side and readjust my hands and everything. Hold everything straight. Now I'm going to try from this side. And right here at this side, you can see right over here it binds up. So it looks like just right at that middle portion, it falls just under 0.002, according to this measurement, which I found strange. Further discussion on this matter reveals that the piston has to be perfectly straight. So if you insert the feeler gauge first, since it's so incredibly thin, it'll straighten out the piston when it's inserted. So I'm just inserting it first, and then I want to get it all the way past the point where the piston is the widest, obviously, to take that accurate measurement. So I'll drop the piston down, and it goes in without a problem, because the piston is, in fact, bigger than 2000. So here we go. I'll drop the piston in. No resistance. Slides out. Slides all the way back. So whatever it is greater than 2000. It's fine. That's how this test works. I'm actually using rem oil just to clean the cross hatching, so we don't get any rusting while it's cleaned. I don't want to have any of the oil removed from this cast iron. Now I'm going to coat this ring in 60 weight oil. Next I'm going to coat the entire cylinder in way too much 60 weight oil. Now manually compress this ring into the cylinder. Just get it started just a little. And then I'll use the piston to make it straight, and then guide it all the way down about an inch just around before the top of the cylinder on the other side. I removed the piston, and now I could set up to take measurements. Here we have 16 thousandths goes in, no problem at all. 17 thousandths has a bite to it, but it passes. 18 thousandths is a no-go. 17 thousandths it is. Definitely 16, 17, somewhere between there. So now I'll push that ring out the rest of the way with the piston from the bottom. Catch it from the top. Just very gently. There we go. Put that away in one. Pull the piston out. Now prepare for ring 2. With everything all set up, measure at 17 is good. Move on to 18. 18, no way. So 17 it is. Repeat the same process on the other cylinder with the other set of rings. "17 fits. 18 does not. 17 it is. "17 fits, no problem. 18, no way. So 17 it is." So as I push this ring out, we come to find that all rings are 17 thousandths of an inch. This concludes the measuring of the ring gap in the cylinders. And that concludes this portion of the project. Still going to have to measure the rings once fitted into the pistons themselves. That'll be a last measurement. But we're really going to have to clean up the face of these pistons, especially these sharp edges. We don't want any hot spots causing detonation. That'll also have to be done. And then, yeah, we'll move onward and continue with this project. I hope you enjoyed this video, found it entertaining. Hit that like button down below and subscribe button for more videos. When the next video comes out, I'll post a link up above. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?